Hello everyone. In this tutorial, we are going to talk about the transformations of tangent and cotangent graphs. So don't forget to share this video to other people. Let's get started. I would like to start with the general form of tangent and cotangent functions. Y equal to a multiplied by tangent of bx plus c plus d. This is the general form of tangent function for which a, b, c, and d are all constants. Y equal to a multiplied by cotangent of bx plus c plus d. This is the general form of cotangent function. So next, we need to understand the effects of this a, b, c, and d. Let's start with a. A here is not the amplitude. Rather, it has some effects on the graph. It may either stretchen the graph vertically. It depends on the value. If the absolute value of a is greater than 1, then the graph will be stretched vertically. Then if the absolute value of a is between 0 to 1, then it will compress the graph vertically as well. And if a is negative, it will definitely reflect the graph along or about x-axis. Then moving on, we have b here. We use b to determine the period. Remember the mother function, we are coming to that. It has a period of pi. Then to determine the period of the transformation, you have to take that pi and divide by b. Then to determine how many units you are going to shift the graph either to the right or to the left, you're going to take c and divide by b. If the value you obtain is negative, then you should shift the graph to the right. How many units? C over b. Then if it is positive, then you shift the graph c over b units to the left. Then d here, if d is positive, then it means that every single point will be shifted d units above. That is vertically. But if it is negative, you shift it down. So now let us start with the mother function, which is, let me start with tangent. If you are given y equal to tangent of x, this is the mother function. So how can we graph this? Let me use multiples of pi over 2. We have pi over 2 here. We have 2 pi over 2, 3 pi over 2, and we have 2 pi. If you come to the left, we have negative pi over 2, we have negative pi, we have negative 3 pi divided by 2, and lastly we have negative 2 pi. Remember that tangent and cotangent are all rational functions. So tangent x is equal to sine x divided by cos x. So since it is a rational function, we don't want any situation that will make the denominator to be equal to 0. Therefore, we have to determine those values of x that will make cosine to be equal to 0. Well, we know that cosine of pi divided by 2 is 0. So the graph will never cross pi over 2. So we are going to have a vertical asymptote here. Likewise here, right? The graph will never pass that point. Then at which point again? We know that at 3 pi over 2 also, which is equivalent to 270 degrees, cosine of this value is also 0. So we don't want any situation that will make our denominator to be equal to 0. That is from 0 to 2 pi, because it is equal to 1 here. Then coming to the left, we have a reflection of that, so we're going to have another vertical asymptote here. All right. We also need to determine where sine is 0. I know that sine of 0 is 0, so we have a point here. I remember in between 0 and 90 degrees, because pi over 2 is 90 degrees, we have 45 degrees here. or pi over 4. And you know, both sine and cosine of pi over 4 are the same. So if you divide, you get 1. So maybe we have 1 here and we have -1 here. So at pi over 4, you have a point here. At negative pi over 4, you have a point here at -1. So you see, this will keep on repeating. Then sine is 0 here, right? Sine is 0 here. Sine is also 0 here. But we have some point in between them, which is going to be a copy of these points. So under here, you have a point here. Here you have a point here. If this is pi over 4, this is 2 pi over 4. This is going to be 3 pi over 4. This is 4 pi over 4, remember. This is 5 pi over 4. So under 5 pi over 4, tangent of 5 pi over 4 will give you 1 again. So all of this, you're going to repeat them to the left. As the graph will never cross this asymptote, it is going to look something like this. It can come closer and closer, but it will never pass the asymptote. Similarly, we have an arrow here. So we have this one as well. So this is typically how the graph of tangent function looks like. That is the mother function before we come to the transformation. But subsequently, I'm going to pay attention to only one period. You can see if you consider this one, half of the graph is to the right of y-axis and half is to the left. So I'm going to consider only from negative pi over 2 to positive pi over 2. If you look at the distance between negative pi over 2 to pi over 2, you're going to get pi, right? That is the distance, which implies that tangent function has a period of what? Pi. That is the mother function, unless if there is any transformation. Then what about range? You can see that the graph keeps on moving up forever and down forever. Therefore, the range is what? All real number, or from negative infinity to positive infinity. So let me see if I can write it here. The range, okay, let me say from negative infinity to positive infinity. Okay. This is the range. But for the domain, you see we have some restriction, or you can say it is what? The set of all real number x such that this x can never be equal to all the vertical asymptotes. We have one here, which is pi over 2. Then we have 3 pi over 2. But if you observe, from pi over 2 to 3 pi over 2, we have an addition of pi. If you come back from this point to this point, you have a subtraction of pi. So it means that all except pi over 2 plus n pi. N is an integer. It could be negative or positive, right? So assuming it is 0, you have 0 times pi. So you see at pi over 2, we have an asymptote. If it is 1, if you add 1 here, it becomes 3 pi over 2. So this is the domain and this is the range. So this is for what? Tangent. So now let us look on to cotangent. I have explained this already, so I think I can take it down. We have pi over 2. We have 2 pi over 2, which is simply pi. We have 3 pi over 2. I think I'm going to stop here. To the left, we have negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. All right, remember that cotangent x is equal to what? Cosine of x divided by sine of x, because it is a reciprocal of what? Tangent. So we need to determine points where sine is equal to 0, because we don't want any situation that will make the bottom to be equal to 0. Well, I know that sine is 0 at 0 or 360 degrees. So at origin, we have a vertical asymptote here. Then we know that sine is equal to 0 at pi, so we have another vertical asymptote here. Then at 2 pi, I don't want it to mix with that one, so leave it like this. If you come to the left, we have another one here. Negative 2 pi, negative pi, pi, and 2 pi. We don't want x to be equal to all of these values. We have infinitely many of them, remember, because we have so many coterminal angles. So these are our vertical asymptotes. Our graph will never cross this. Then we need to determine where cosine is 0. Cosine is 0 at pi over 2. We have a point here. Cosine is 0 where again? Here. So let's just repeat this one to the left. We have a point here, we have a point here. Then we need to determine where both cosine and sine are exactly the same. Remember, at this we have 45 degrees or pi over 4. It is equal to 1. So assuming we have 1 here, we have negative 1 here. So we have a point here under 45 degrees. And here we have negative 1. That is, if this is pi over 4, this is 2 pi over 4, this is 3 pi over 4. Under 3 pi over 4 in the second quadrant, we have negative 1. So if you construct this graph, it will look like this. You see that? This one is coming down from the left to the right, but this one is going up from left to the right. It means that there is a significant relationship between this and this. We are coming to that. So we're going to repeat all of this. We have a point here. We have a point here. So this is how the graph of cotangent looks like. But there's something you should observe. You see that tangent started or passes through the origin 0. But this one has been shifted pi over 2 units to the right. And this one is coming from the top right to the bottom left, while this one is coming from the top left to the bottom right, which means there is a reflection between this. Because if you take this point up, you take this point down, it is going to look like this. This implies that the graph of cotangent of x is a reflection of tangent. Tangent of what? X. But look at it. It has been shifted to the right pi over 2 units. Right? So it means that if you shift the graph of tangent to the right pi over 2 units, you know you're going to subtract pi over 2 units. So it implies that cotangent of x is equal to negative tangent of x minus pi over 2. This is the relationship between them. And this is always true. So now let us talk about the range and the domain. The range are all real numbers, right? So range, all real numbers. Because you can see from bottom to the top, it is going forever. But what about the domain? They are all set of real numbers x, but we don't want anything that will make this x to be equal to what? All the asymptote, you see? 0 is an asymptote, pi is an asymptote. From pi to pi, you have 2 pi. So it is a multiple of pi. So we have n pi. All the multiples of pi. We don't want our x to be equal to that value. So this is all about the modal functions. Now let us look at some of the transformations. But I have more space to do that. Instead, I'm going to pay attention to only one period. So for this, I'm going to remove this. You see that? This is one period from the origin to pi for cotangent. But this one, half of the graph is to the left and the other one is to the right. So let me take down this. I'm going to be using one period. The rest are just repetition of what you have. Should I take this one closer to that? Okay, let me see if I can construct it here. So you can see we have our two graphs here. This is for tangent of x and this is for cotangent of x. Let me use this side for all the transformations. All right, we have our first problem here, which we are asked to construct the graph of 2 multiplied by tangent of x. 2 multiplied by tangent of x. Just observe, the only difference between the molar function and this is this 2. And this 2, remember, is our e. So it is going to straighten the graph vertically with a scale factor of 2. So if this point is 1, you multiply it by 2, it will reach after 2. If this is 2, maybe this is -2. So this point will be here and this other point will be down here. That is just the difference between them. It is just going to straighten the graph vertically. So we have something like this, but all other things remain the same. We have the period is what? Pi. So because half of the graph is to the right and half is to the left, this is why we have half of pi over 2 here and the other part here. So we have pi over 2, negative pi over 2. Our scale is up to 2, right? And this is up to -2. All other points remain the same. At 45 degrees or pi over 4, we used to have 1, but this time around, because it has been multiplied by 2, it will reach here. And this one, which is -45 degrees, it will reach -2. You see that? So the graph will look like this. Remember, this is our vertical asymptote. All right? So the graph will come like this, pass through the origin, back to this point, then down. It will continue going down and up, but no matter what, it will never touch this axis because we have a vertical asymptote. So this is the graph of what? 2 tangent of x. It has been straightened vertically. Now let us move on to the second problem here. The second problem here, we are asked to construct the graph of 1/2 cotangent of x. Almost similar to this one, but this one has been compressed. You see, the value is 1/2, and I told you if the absolute value of a is between 0 to 1, the graph is going to be compressed. So everything will remain the same. We have pi over 2. I'm going to restrict my graph to only one period. Remember, you can construct or repeat all other axes. All right, for cotangent, we have an asymptote here, which is a vertical asymptote. Then we have a point here at pi over 2, but all other points of y will be divided by 2. So if, assuming this is 1, this will be 1/2. If this is -1, this will be -1/2. So the graph will be compressed. Remember, this is supposed to be at 1, but since it is being divided by 2, you have to have your point right here. Then at this point, you have your point at 1/2. So the graph will look like this. This is just one period. You could have other points like this, infinitely many of them. Like this, you understand? So this is our second problem. This is the second transformation. Then the third transformation is a reflection. We are asked to construct negative tangent of x. We have pi over 2 to the left, to the right. We have negative pi over 2 to the left. All right. Remember, the origin will not change. This is going to be a reflection about x-axis. So every single point to the top will be shifted down. Remember at 45 degrees, let me draw my asymptotes. At 45 degrees, we used to have a value of 1. Maybe this is 1, this is -1. But it is going to be reflected down. At -45 degrees or -pi/4, we used to have -1, but it is going to be reflected back to 1. You see that? The graph is now going to come like this, pass through the origin down to this other point. So this is how the graph of negative tangent of x looks like. You see that? This point is now down here, and this other point that used to be here, it is now up here because of this negative sign. Next transformation, we're asked to transform cotangent of x. Y equal to negative cotangent of x. Similar to this one. You remember we used to have pi/2 here. We used to have pi here. We have our two asymptotes, one at origin and one at pi. Then this point here, which is pi/4, used to be at 1. But now it is going to drop down to -1. This is 3pi/4, right? This is 3pi/4. There used to be at -1. It will now be at +1 because there is a reflection. So the graph will look like this. You see that? You know, it passes through this point. So this is the reflection of cotangent graph, which is similar to tangent graph, just that it has been shifted to the right pi/2 units. This is our fourth transformation. Now let us talk about horizontal stretch. Tangent of 2x. Remember, this is our b. And to determine the period, you have to take pi and divide by this number. So the period, well, let me just call it p, is equal to pi divided by b, and b is 2. So the period is what? Pi/2. The period here for the molar function is pi. But since half is to the left, half is to the right, so we divided that pi by 2, we have pi/2. We are equally going to divide this by 2 because we are transforming the graph. So this is the period. We are going to divide this by 2 so that this becomes pi/4. All right? To the left, we're going to have -pi/4. You repeat everything. Remember, you used to have a point here. This is 1, this is -1. You used to have, this is tangent, remember? So between the this is now going to be a vertical asymptote. The vertical asymptote that used to be at pi/2, it is now at pi/4 because the graph has been compressed horizontally. So the vertical asymptote is now halfway. Remember, this is 45 degrees. Half of this is going to be pi/8. So at pi/8, you're going to have a point here. Negative pi/8, you're going to have another point here. So the graph will look like this. One complete period. You could have so many other points to the right and to the left. You understand? But I'm just paying attention to one period. Next, we are going to construct the graph of cotangent 1/2x. Cotangent of 1/2x. This time around, the graph will be what? Straightened horizontally. So the period will be equal to pi divided by 1/2, which is simply 2 pi. Right? This is cotangent, remember. For cotangent, we used to have a vertical asymptote at pi. But this time around, since it has been doubled, we are going to have our vertical asymptote at 2 pi. So this is our vertical asymptote. We're going to have another one at origin. So what will be this one? This will be pi, right? So we're going to have another point here. Remember, this is cotangent. Then in between pi and 0, we're going to have a point at 1. In between pi and 2 pi, you're going to have another point at -1. So the graph will look like this. This is the graph of what? Cotangent 1/2x. The only reason you didn't see the graph widen enough is because of the scale. Remember, on your graph sheet, you have some boxes. You may decide to say, okay, every one box represent pi, if you like, or you can say every 2 boxes represent a single pi. So the main objective is to see the points. You see, we have a point at pi, which is at the origin. That is when cosine is 0, you have a point here. When sine is 0, you have a vertical asymptote. Now let us move on to the next one, which is a reflection. This negative together with x is going to cause a reflection about y-axis. It means that, look at y-axis here. If you turn it like this, all points to the right will come to the left. This is one way. But also you can reflect it about x-axis. Reason, because I know that tangent is odd. This is also equal to negative tangent of x, because tangent is odd. So either you construct this or you construct that. It remains the same. Let me show you mentally. If you reflect this graph along y-axis, you see this point will come here and this point will come here. So the graph will look somehow like the cotangent function. And if you consider this one, which is a reflection about x-axis, if you take this point, you bring it down here, you take this one up, it will going to be similar to this one. So instead, I'm going to reflect it. Well, it's all the same. We have pi over 2 here. We have negative pi over 2 here as well. We have 1 and we have -1. All right. So instead of having a point here, remember this is our vertical asymptote. Instead of having a point here, I'm now going to drop it down here. Instead of having a point here, it is now coming up here. So this is a reflection. So this is the graph of tangent of negative x or negative tangent of x. They are all the same. Then we also have y equal to cotangent of negative x. Also similar. Cotangent of negative x. It's also the same thing as negative cotangent of x, but this time around, let me show you how you can reflect it along y-axis. We have pi over 2 here, and we have pi. This is our vertical asymptote for cotangent. This is another vertical asymptote. All right, this point will now be here, right? It is now going to be here. And this point that used to be here, it is now going to be here at, if this is 1, this is -1. So remember, it is going to pass through pi over 2. So the graph will look like this. This is what? A reflection about y-axis. I have taken this point to this, and this point to this one. Reflection. Or you can simply take this point up, you bring this down. They mean the same thing. Moving to the next one, this time around we're going to talk about phase shift or horizontal shift. This is going to be a horizontal shift to the right because it is negative. If it is positive, you shift it to the left. If there is a number attached to x, which is a coefficient of x, you have to first of all take this value, you divide by the leading coefficient. But since there is no any number here, literally it is equal to 1. You don't have to divide by 1. So let me show you. All right. Since the graph has been shifted pi over 4 units to the right. You see, this is your origin, right? You're going to assume you have an imaginary y-axis at pi over 4. Though this is not a vertical asymptote. Should I remove it? This is at pi over 4 because every single point will be shifted pi over 4 units. So even this vertical asymptote that is to be at pi over 2 will have to be shifted here. So I think let me remove this one. I know I can explain it. Our vertical asymptote used to be here, but you remember we have an additional of pi over 4 here. This is 1 pi over 4, this is 2 pi over 4, this is 3 pi over 4. So at 3 pi over 4, you have your vertical asymptote. Right? Even this one, it is going to be shifted here. Halfway, right? In between them. Then, your origin will be shifted pi over 4 units. So it will be here. So you are going to construct the graph in between this vertical asymptote to this one. That is your first period. This is 1, this is -1. Remember, we used to have a point under pi over 4, which is supposed to be here, but it is now going to be shifted pi over 4 units to the right as well. So you have a point under pi over 2. I remember under negative pi over 4, we used to have a point here, which is going to be shifted exactly on the main y-axis. So the graph will look like this. Something like this. So this is now the graph of what? Tangent of x minus pi over 4. Everything has been shifted pi over 4 units to the right. Let us move on to the next transformation. Cotangent, remember this is that. Because this is positive, it is going to be shifted to the left. We have pi over 2 here, we have pi here. If you come to the left, we have negative pi over 2, we have negative pi. Remember your vertical asymptote, very important, which is at pi. But because it has been shifted pi over 2 units to the left, this is pi over 2 units, right? So this is now going to be your vertical asymptote. Next, at origin, you used to have a vertical asymptote, which is going to be shifted to the left, pi over 2 unit as well. So, in between 0 and pi, you used to have pi over 2, but this time around, you're going to have what? Origin, right? So it is going to pass through the origin. Then here, there is to be at -1, it will remain at -1, because the graph is now going to be between the two vertical asymptotes. You see that? So this is what? The transformation of cotangent of x plus pi divided by 2. Everything has been shifted to the left, pi over 2 units. Now let us move on to the next one, which is a combination of all. This is our first problem. We would like to construct this graph. Number one, you should know that instead of this point at 1, it is now going to be after 3. So let me do it. Because of this minus, the graph is going to be shifted to the right. But first of all, let us talk about the period. The period, remember, it is equal to pi divided by the coefficient of x. So the period will be what? Pi over 2. I remember 1 is to the left, 1 is to the right. So we're going to have pi over what? Pi over 4. And negative pi over 4. Next one, if this is 1 pi over 4, the next one will be 2 pi over 4, or simply pi over 2. This is going to be 3 pi over 4, and so on. There is going to be a shift, right? We need to determine the shift. So the vertical, assuming we don't have this negative pi over 2, our new vertical asymptote will be at what? It will be at pi over 4. But there's going to be a shift. And how can we determine that shift? We're going to take negative pi over 2 and divide it by the coefficient of x. And this will going to give us what? Negative pi over 4. So this is going to shift the graph negative pi over 4 to the right. So where is, we used to have a point here, right? At origin, it is now going to come here. And our vertical asymptote that used to be here at the first line, it is now going to be at the second point. Our vertical asymptote that is here will now be at origin. You see that? Then what next? There's going to be a shift 1 unit above. So assuming we have 1 here, we have negative 1 here. Remember, because of this 3, we're going to multiply this by 3. So we have, let me scale it very much tiny. We have 1, we have 2, we have 3, we have 4. So it will reach after 4. I'm going to explain that for you. It's supposed to stop at 3 and negative 3. Negative 1, negative 2, negative 3. It's supposed to stop at from negative 3 down to 3 because of this scale factor of 3. But the graph has been shifted 1 unit above. So it is going to reach the maximum 4 here. That point that we used to have at 1 will now reach 4. Okay. But this remains where it is at origin. So this is now our imaginary y-axis at pi over 4. So here we used to have point at what? 1, but it is now going to be after 4. At this point that we used to have a point down to 1, it is now going to be after 2. Why? It's supposed to be after negative 3, but it has been shifted 1 unit above from 3 to 4, from negative 3 to negative 2. So the point will stop here. And sorry, this point will no longer be here. It will be after here because every single point has been shifted 1 unit above. This is the graph of 3 tangent of 2x minus pi over 2 plus 1. Now let us look at the second to the last problem here. We have y equal to negative 2 cotangent of 1 over 2x plus pi divided by 2, then minus 1. Because of this positive sign, the graph will be shifted to the left. So I have something like this. Let's talk about the period first. P is pi divided by the coefficient of x, which is 1 over 2. This will give us 2 pi. The period is pi, right? So we have 1, 2. Then we used to have pi. It will now be 2 pi. So between origin and this, if you divide by 2, you have pi. This is now pi. Okay. Next, we need to talk about the shift. The shift, you have to take this and divide by this. Pi over 2 divided by 1 over 2 will give us pi. Because it is positive, it is going to shift the graph to the left, pi units. So remember, we used to have our vertical asymptote at the second point. So now it will be shifted pi unit to the left. So your vertical asymptote is now here. Another vertical asymptote at origin will be shifted down here. Remember, we used to have 1 to negative 1, right? But this time around, because it has been multiplied by 2, first of all, consider the absolute value of negative 2, which is 2. So it will be after 2 down to negative 2. Next, you see that we have the d value is negative 1, meaning it is going to shift the graph down. How many units? 1 unit. So from here, it will drop down here. From here, it will drop down to negative 3. So remember, always your graph will be between the vertical asymptotes. So let's compare. the points in between origin or the first vertical asymptote and the first point is at maximum, right? Between the vertical asymptote and the first point, this is our first point at origin. So here is to be at maximum, but this time around, because we have a negative sign here, it is going to reflect to the minimum. Then remember, we used to have a point here. This is the first value here from our first vertical asymptote. This is our first vertical asymptote, so it is going to be here, but has been shifted down, so at -1. Then we used to have a point here at minimum. So this value here that's supposed to be at minimum, it will be at maximum, and the maximum is now 1. So let's connect. This is now the graph of -2 cotangent of 1 over 2x plus pi over 2 minus 1. Then our last problem. This is our last problem. All right. You see this value is negative. So if we like, we can bring the negative outside. So the moment you bring the negative outside, it becomes tangent of negative. The whole of every sign will change. You have 2x, then minus pi. Then because tangent is odd, you can bring the negative here, exactly here. So y becomes this. So instead of constructing this, we can now construct this.